In this lecture, we will see the mathematical problems regarding the practical transformer on no load condition. At first, we need to familiarize ourselves with the formulas. So, the no load current I naught can be calculated as root over IW square plus IM square, and magnetizing current IM can be calculated as root over I naught square minus IW square, and the loss component of the current IW can be calculated as root over I naught square minus IM square. Again, the no load power factor cos phi naught can be calculated as IW divided by I naught, and by using this no load power factor, we can calculate loss component of the current IW as I naught cos phi naught, and the magnetizing component of the current IM as I naught sin phi naught. And no load power, which is also equal to the core loss of the practical transformer, is equal to P naught V1 I naught cos phi naught or V1 IW. And exciting resistance R naught is equal to V1 by IW, and exciting reactance X naught is equal to V1 by IM. Now let's look at some problems. Our first problem, where a 230 by 110 volt single phase transformer has a core loss of 100 watt. If the input under the no load condition is 400 volt ampere, then find the core loss current, magnetizing current, and no load power factor angle. So we can see that input at no load or V1 I naught is equal to 400 volt ampere. Primary voltage V1 is equal to 230 volt, and secondary voltage V2 is equal to 110 volt. And no load power or core loss P naught is equal to 100 watt. So the no load current I naught is input power at no load, which is V1 I naught divided by primary voltage V1, and the value of V1 I naught is 400, and the value of the primary voltage V1 is 230 volt, from where we can calculate I naught as 1.739 ampere. And we know that core loss component of the current or IW is equal to core loss divided by supply voltage V1. So IW is equal to P naught by V1, or IW is equal to 100 by 230, which will be equal to 0.4348 ampere. Now from the value of loss component of the current and the no load current, we can calculate the magnetizing component of the current, which is IM, and IM can be written as root over I naught square minus IW square. By putting the value of I naught and IW, we can calculate IM as 1.648 ampere. Again, the no load power factor cos phi naught is equal to IW by I naught, where we have already calculated the value of loss component of the current or IW as 0.4348, and no load component of the current I naught as 1.739, from where we can calculate the angle cos phi naught as 75 degree. Now let's move on to the next question. We have a single phase transformer with 50 kVA no load power, and supply is 2300 by 230 volts and 50 hertz frequency, which is connected to 230 volt supply on the secondary side, and the primary is being open. The meter indicate the following readings: power is equal to 230 watt, voltage is equal to 230 volt, and the current is equal to 6.5 ampere. We need to find the core loss component of the current, magnetizing current. And first of all, as the transformer operates in no load condition, the input power is equal to core loss. That's why core loss P naught is equal to 230 watt. 230 volt supply is given on the secondary side of the transformer, so we can say the supply voltage V1 is equal to 230 volt, and the reading of the current 6.5 ampere can be considered as no load current I naught, because transformer operates on the no load condition. So we know that the no load power P naught is equal to V1 I naught cos phi naught, which will be equal to 230 watt, and it is also equal to the core loss, from where we can calculate the no load power factor cos phi naught as 230 divided by 230 into 6.5, which will result in 0.154, and from where we can calculate the power factor angle phi naught as 81.14 degree. We know that the loss component of the current IW is equal to I naught cos phi naught. By putting the value of cos phi naught as 0.154, we can calculate the loss component of the current as 1 ampere, and we also know that the magnetizing component of the current IM is equal to I naught sin phi naught, or I naught sin 81.14 degree, which will result in 6.5 into 0.988 or 6.422 ampere. In the next question, we are given 230 volt 50 hertz transformer with the 200 primary turns, and it draws 5 ampere at 0.25 lagging power factor at no load. So we need to calculate the maximum value of flux in the core, magnetizing current, core loss, and exciting resistance and reactance. At first, we can see that the transformer is at no load condition. So the primary voltage V1 will be equal to U1 will be equal to 230 volt, and the primary number of turns is 200. And also the no load current is given as 5 ampere, and the power factor cos phi naught is equal to 0.25. By using the primary voltage U1 is equal to 230 volt, we can write the equation of the transformer, which is 4.44 N1 F phi m equal to 230 volt. By putting the value of N1 as 200 and F as 50 Hertz, we can calculate phi m as 5.18 microwaver. Now we know that the core loss P naught is equal to V1 I naught cos phi naught. By putting the value of V1 as 230, I naught as 5 ampere, and cos phi naught as 0.25, we can calculate this core loss as 287.5 watt. Now the no load power factor cos phi naught is given as 0.25 lagging, and from where we can calculate the power factor angle as 72.52 degree. So the loss component of the current IW is equal to I naught cos phi naught. By putting the value of I naught as 5 and cos phi naught as 0.25, we can calculate this loss component of the current IW as 1.25 ampere. Similarly, we can also calculate the magnetizing component of the current IM, which is equal to I naught sin phi naught, and by putting the value of sin phi naught as 75.52 degree and I naught as 5 ampere, we can calculate the magnetizing current IM as 4.84 ampere. Again, the exciting resistance R naught is equal to V1 by IW, which can be calculated as 230 divided by 1.25, which is equal to 184 ohm, and the exciting reactance X naught is equal to V1 divided by IM, which is equal to 230 divided by 4.84 or 47.54 ohm. For the final problem of this session, we have an open circuit transformer with 10 kVA no load input and 500 by 230 volt supply. 50 Hz transformer which draws a power of 167 watt at 0.745 ampere and 500 volt. Now we need to determine the watt-full current, no load power factor, and hysteresis angle of advance, and equivalent resistance and reactance of the circuit. At first, the primary voltage V1 is equal to 500 volt, and the no load current I naught is given as 0.745 ampere. We know that the core loss P naught is equal to V1 I naught cos phi naught, which is equal to 167 watt. From where we can calculate the no load power factor cos phi naught as 167 divided by 500 into 0.745 ampere, which will result in 0.4483, and from where we can also calculate the power factor angle phi naught as 63.365 degree. Now the loss component of the current IW is equal to I naught cos phi naught, and by putting the value of I naught as 0.745 and cos phi naught as 0.25, we can calculate the loss component of the current IW as 0.334 ampere. Again, we can calculate the magnetizing component of the current IM as I naught sin phi naught, which is equal to 0.745 into sin 63.365 degree or 0.968, which will be equal to 0.6658 ampere. Again, we can calculate the exciting resistance R naught as V1 by IW, which will be equal to 500 divided by 0.334 ampere or 1497 ohm, and exciting reactance X naught is equal to V1 by IM, which is equal to 500 divided by 0.6658 ampere or 750 ohm. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.